Good day, Earth Science students. Welcome to video lecture episode 18. Remember last time we left finishing up the discussion with a question that said, what causes the day to become night and then change back into day, and referring to ellipses. Okay, not ellipses, excuse me, eclipses. Okay, let me get that correct. Okay, so let's move to slide 94 and let's continue this discussion on eclipses by asking a question. What causes an eclipse? Well, the revolution of the moon causes eclipses. That's what causes them. Eclipses occur when Earth or the moon temporarily blocks the sunlight from reaching the other. Okay? Sometimes during a new moon, the moon's shadow falls on Earth and causes a solar eclipse. During a full moon, Earth's shadow can be cast on the moon, resulting in a lunar eclipse. And if you look on slide 95, I have an image representing that. Now, an eclipse can only occur when the sun, the moon, and Earth are lined up perfectly. Because the moon's orbit is not in the same plane as Earth's orbit around the sun, eclipses actually only occur a few times each year. Now, a solar eclipse occurs when the moon moves directly between the sun and Earth and casts its shadow over part of the Earth. You can see this on the images I have on slide 97. And we're talking about right now just eclipses of the sun. Now, depending on where you are on Earth, you may experience a total eclipse or a partial eclipse. And if you look on slide, like I said, slide 97, it shows you the difference between a partial and a total eclipse. All right, so let's move to slide 98. The darkest portion of the moon's shadow is called the umbra. A person standing within the umbra experiences what we call a total solar eclipse. And you can see that, once again, represented on the graphic image on slide 98. Now let's continue our discussion about eclipses of the sun. During a total solar eclipse, the only visible portion of the sun is a pearly white glow around the edge of the eclipsing moon. Surrounding the umbra is a lighter shadow on Earth's surface called the penumbra. And like I said, you can see this in slide 99 as well as slide 98. The image is the same and it represents both where the umbra and the penumbra are, graphically speaking. Alright? Now let's just try to close up our discussion a little bit on eclipses of the sun so we can move on to eclipses of the moon. Persons standing in the penumbra experience what we call a partial solar eclipse. Now, there's a quick little warning I just want to mention here. Regardless of where you stand, never, and I mean never, look directly at the sun during an eclipse. The light can actually permanently damage your eyes. Alright? Now let's move into eclipses of the moon. Now, when Earth's shadow falls on the moon, a lunar solar eclipse occurs. A lunar eclipse begins when the moon moves into Earth's penumbra. Alright? As the moon continues to move, it enters Earth's umbra, and you see a curved shadow on the moon's surface. Now, if you look on slide 102, I have a graphic representation for that. Now, upon moving completely into Earth's umbra, the moon goes dark, signaling that the total lunar eclipse has occurred. Now, sometimes sunlight bent through Earth's atmosphere causes the eclipsed moon to appear red. Just in case you were curious, that's pretty cool to think about, that because of the way the light's being bent, it causes the color of the moon to change. Now, a partial lunar eclipse occurs only when a portion of the moon moves into Earth's umbra, so that's the difference between more of a partial versus a total. Alright? Now, the remainder of the moon is in Earth's penumbra, and therefore receives some direct sunlight. Now, a penumbral lunar eclipse occurs when the moon is totally within Earth's penumbra. Alright? Now, let's move to slide 105, because I want to talk a little bit about, or at least show graphically that what it looks like when the moon can look a little red. Now, however, it is difficult to tell when a penumbral lunar eclipse occurs because some direct sunlight is falling on the side of the moon facing Earth. A total lunar eclipse can be seen by anyone on the nighttime side of Earth where the moon is not hidden by clouds. This is just some things to consider. Now, if you look at slide 106, you can see the differences of different phases of the moon based on if we're going into an eclipse versus just the normal phases of the moon. Alright, we're going to go ahead and close our discussion with slide 107. I just want to mention this. In contrast, in other words, where we were talking about how it was hard, sometimes to tell the difference, or it was hard to see it, so to speak, only a lucky few people get to witness a total solar eclipse. In other words, it's a small group, just depends on a portion of the Earth. Only those people in the small region where the moon's umbra strikes Earth can witness. Okay? So that's why not everybody gets to see this, and it varies from year to year. Alright, I do hope this lecture has been helpful. If you have any questions, you can leave it in the comments below. Reach out to me via email. I hope this has been helpful. Have a nice day. Take care.